So for section 4.2, we're continuing on using the same concepts as 4.1. However, we're going to start adding them to some real world scenarios as we get further through our examples. So if we look at example 1, it says that we're looking for x and y. So this is very similar to examples that we've seen in 4.1. If I look, I'm looking for x. This is my hypotenuse in the top triangle here. If I look at 40, this side length would be my adjacent. Okay, so I'm looking for x so that I can also solve for y here. So if I'm looking at hypotenuse and adjacent, I'm going to want to use cosine of theta, which is adjacent over hypotenuse. Okay, so I'll do cos of 40 equals 6.4 over, and in this case, the hypotenuse is labeled as x. I'll grab our calculator here. So to solve for this, I'm going to take 6.4 times 1 divided by cos of 40. So I'll get we'll go to one decimal place, 8.4. And I'll just slide that back over. Okay, so now I know that x is equal to 8.4. Okay, the last piece of information I need is this here, this y. Y, if I look next to the 68 degrees in this triangle, this is going to be my adjacent. And now this side length here, where the x is different, right? We're looking at a different triangle. So from this 68, this is my opposite. So to figure out what y is, I have adjacent and opposite. I'm going to use tan. So tan of theta equals opposite over adjacent. So tan of 68 equals 8.4 over y. If I solve for y, I'm going to take 8.4 times 1 divided by tan of 68. So then y is equal to 3.4. Okay. So that would be my solution here for x and y. And it's helpful to box your answers. Okay, for example 2, we're looking for x, y, and h in the following diagram. So I want x, y, and h. So I'm going to start by looking at this and figuring, okay, what information do I have already? So if I look, I can kind of see that I have one large triangle here. Okay, as well as I have some smaller triangles, right? So if I look, I could start by finding h because I have the hypotenuse of the large triangle, I have the angle, and h in this large triangle would be my opposite. So if I figure that out, so this would be my opposite. I have opposite and hypotenuse. So I want to use sine. Okay, so sine of 53 degrees is equal to h over 21.4. And again, if it helps you, we're going to go 21.4 times sine of 53 divided by 1. Divided by 1 will give me the same thing. This will be 17.1. So h is equal to 17.1. So here, this is 17.1. Now, I know that this whole side is 17.1. And I know this piece of it is 8.6. So what I can do is to figure out what x is by subtracting 17.1 minus 8.6. So x is equal to 17.1 minus 8.6. Which will give me 8.5. Okay, so I have two pieces of information here. So now I know that this piece here is 8.5, and I'm just gonna erase some of the highlighting here. So now all I need to find left is y. So what I'm going to look at is that I still have this large triangle. And I have the angle and I have a side length. So what I'm actually going to do is figure out what this adjacent side, this entire adjacent side, would be. And once I know that, this whole length, I could take that answer and subtract the 6.5 to figure out what y will be. So I like to use the numbers that are already given if possible. So I'm going to use this 21.4. So I have adjacent and I have my hypotenuse, so I'm going to use cosine of 53 degrees equals adjacent's what we're looking for. Let's call it x. And my hypotenuse is 21.4. Making sure we're plugging in our right values there. So I'm going to go 21.4 times cos of 53. And I get 12.9. So, and I guess this was really y. No, it's actually not y because y is a part of it. We'll just leave that as x for now. So if I want to figure out what just y is, I'm going to take the 12.9 minus 6.5. Okay, so 12.9 minus 6.5, and we get 6.4. So 6.4 here, so y is equal to 6.4. So now we have all of the information that it's asking us for. Okay. Number 3 says we have a flagpole supported by 2 wires, each attached to a peg in the ground 4 meters from the base of the pole. So imagine we have a flagpole. Okay, and the flagpole is supported by 2 wires, so we have 1 wire and 2 wires, each attached to a peg 4 meters from the base. So that means, I can expand this a little bit, that this is 4 and this is 4. The guy wires have an angle of elevation. One is 35 degrees and one is 45. It doesn't matter which side we put these on. So how much higher up the flagpole is the top wire attached? So when we think about this flagpole, and I'll redraw this a little bit, is that one of these wires that has a lower angle of elevation is actually going to attach lower. So there is a different way we could draw this diagram, but this works as well. So we want to know how much higher is the top wire than the bottom one. So we want to find this distance here. So in order to do that, what I need to figure out is what is the height of on each side of these triangles. So if I look, I want to figure out the height here, and I want to figure out this total height, okay, in order to figure out that green height. So to start, I'm going to start working on the left side. So I know that it's 4 meters here, which is my adjacent side. The height is an opposite side, so I'm gonna use 10. So 10 of 35 is equal to, and I'll say height over 4. Okay, so then I'm going to take 4, clear this out, 4 times 10 of 35. So my height here will be 2.8. Okay, so that'll be the yellow line. There. And to get the other side, I'm gonna do the same thing. The 4 is gonna be my adjacent, the height is my opposite, so I'm also using 10, but in this case I'm using 45. And I'll call this height 2 over 4. So again, 4, 10 of 45, which is just the same as multiplying it. I'll get the height 2 of being 4 meters. Okay, both of these are in meters because the length that I'm given to start is in meters. Okay, so if I want the height difference between these two, I'm gonna go 4 minus 2.8. So the height difference is going to be 1.2 meters. Okay, and on to question 4. Eloise is standing at the top of a building, so we're looking at right here. She can see that the angle of elevation to the top of the next building is 46. Okay, so that's given in the diagram. And the angle of depression to the bottom of the building is 62 degrees. If the buildings are 30 meters apart, how high is the building? So I'm given information, and this 30 meters, even though it's written down here, it's going to be the same distance right here if I write it, okay? So if I look there, I actually have 2 triangles. I have this right triangle, and I have this right triangle, okay? So what I'm going to do is I need to solve for each portion, and over here it's already labeled at X and Y for us. So I need to solve, I'll write it, for Y here and X here, and I have to do it separately because I have 2 different triangles, and then I'll add them together to get that total height. So if I start with this blue triangle, so I have 46, the 30 is an adjacent side, and then I'm going to look for Y, which is opposite. So opposite and adjacent, I'm going to use 10. So 10 of 45 degrees, or sorry, 46, is equal to my opposite side is Y and my adjacent is 30. And I'm just going to write down the other one as well before I solve for them. So I'm going to still use 10 because I have opposite and I have adjacent with the 30. So I'm going to use 10 of 62 degrees is equal to my opposite, which is the X, over the 30, which is my adjacent. So for both of these, and I can put them over 1 to make it a little bit easier to solve, and we can do like some cross multiplication. So I'm going to go 30 times 10 of 46 divided by 1. So 30 times 10 of 46 divided by 1 is going to give me the same thing. So this is going to be 31.1. And then same thing here. I'm going to go 30, 10 of 62. And this is going to give me 56.4. So if I want the total height, because all this is giving me is this X and this Y separately. So if I want the total height, I have to add them together. So 31.1 plus 56.4. And my total height is going to be 87.5 meters. So that'll be the height of the building. So in most of these questions that we're doing is I usually have to solve more than one triangle to get the total answer, right? So in the one above here, I had to solve for the height of both sides to figure out the difference. In this one, I had to solve for both triangles, figure out x and y, to add it together to get that total height. So that's where it gets a little bit more complicated. If I look at example 4 here, it says that an extension ladder must be used at an angle of elevation of 65 degrees. Its shortest length is 18 feet, fully extended is 32 feet. So it's asking how much higher up the building will it reach when it's fully extended compared to its shorter length. So I'm just going to draw this out so you can kind of get an idea. So it has to be 65 degrees here as an angle of elevation. Okay, at its longest, it's 32. And if I draw this in its shorter position, and my drawings won't be the most accurate here. So this still has to be 65, and this has to be 18. It's asking how much higher up the building will it reach when it's fully extended. So I know that I have a height here, okay, when it's up, when it's extended there. And then I also have height, I'll call this height 1 and height 2. I have height 2, which they're going to be different because they're different extensions. So what we're going to do is solve for both heights and then be able to compare how much higher is it when it's fully extended. Okay, so I'm going to look, I want h, which is the opposite to that angle that I'm given of 65, and the 32 is my hypotenuse. So I'm going to use sine. So sine of 65 degrees equals height 1 over 32. Okay, and we do the exact same thing. The nice thing is that these triangles are actually the same. We just have to change out our hypotenuse. So here my height 2 is my opposite, my hypotenuse is 18. So to solve these, I'm going to go 32 sine of 65. So height 1 is 29, and 18 sine of 65. This is going to be height 2, which is 16.3. So if I'm asking how much higher it goes, so when we're fully extended, it's 29 meters tall. But when we're at our shortest length, it's 16.3. So if I want to know how much higher, I want to know the difference between them. So I'm going to take 29 minus 16.3. Which will be 12.7. So that's how much higher the ladder is at its fully extended length. Now, in order for this ladder to function safely, it says that it has to be at an angle of elevation of 65 degrees. So that means that depending on the length that it's extended, we have to have it at a different width from the base. So part 2 here is asking how much further from the house must the base be when it's fully extended compared to its shortest length. So if I'm thinking about a ladder, okay, this is the ladder, this blue piece. The height up the house is what we just solved for. It's asking how far along the base from the house to the end of the ladder will it be. So if I'm looking here, I'm solving for the adjacent side in both of these. Okay, again, I like to use the information that's already given in the diagram. So I'm going to use my hypotenuse and adjacent. So that means I'm going to use cosine. So I'm going to use cosine of 65 is equal to adjacent over 32. And if we solve for that, so 32 cos of 65, this is going to be at a distance of 13.5 meters. Now let's look at our second triangle here. So same exact thing, I'm going to use cosine of 65, but the only thing that's different is now I'm at its shortest length, which is 18 meters. So I'll go 18 cos of 65, which is 7.6. So again, it says how much further. So that means I want to subtract these. So pay attention to what the question's asking, because it might not just be asking for one thing, right? I might not just be looking for these numbers. I might have to do something with them. So if I subtract these two, I'm able to get how much further the base is required to be out when we're at our tallest length versus at our shortest one in order for this to be safe. Okay, example 6 here. We have like a cane or a rod that's inside a box, and we can see that here. And it gives us the dimensions of the box, and it says what is the longest rod that can be carried in it, so meaning that we're stretching from corner to corner, and what angle does it make with the bottom. So the question is asking us for what is the longest length, so we're looking for L as well as theta. Okay, that's what that symbol is called there. So when I first start looking at this, I'm not given any angles, so it can be a little bit tricky to figure out where to get started. But if I start to look here, I have 15 and I have 12, and I'm just going to highlight here the triangle that we're going to start with. Okay, so that's what we're going to start with on the bottom. This does make a 90-degree angle, right? It's in the corner of a box. So I have two side lengths, and I'm looking for the hypotenuse. So in order to figure out what D is, I'm going to use Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared. So 15 squared plus 12 squared equals c squared. I have two side lengths, and the d is the hypotenuse here. So just make sure that you set that up correctly. And we're going to have to take the square root of the number that we get. So I got 19.2. So that means, and really I'm looking for D here. So I'm going to label that as D. So this is 19.2. And I'm just going to erase that triangle now. So now I need L and I need theta. So at this point, I could solve for either or. Theta, I have opposite and I have adjacent to that angle, okay? The L is the hypotenuse. So using opposite and adjacent, I can use tan to figure out the angle. Okay, my opposite would be 10, my adjacent would be 19.2. Remember that if we're looking for an angle, you have to take inverse tan. So theta here is going to be 27.5 degrees. And then the last piece, I could use Pythagorean theorem again to get L and take 19.2 squared, 10 squared. You could also use your angle that you just figured out and use a trig ratio. Any of those options will work and will get you approximately the same answer when we round. So I'm going to take 19.2 squared plus 10 squared equals, and I'm going to do L here, so I'll write that in. So 19.2 squared plus 10 squared, and I'll take the square root of that number. So I'm going to get L being 21.6. So now I have figured out theta, and I've figured out the maximum length of the rod that can fit in there. And pay attention, because this is in centimeters. Okay, and And we have a couple more questions here. So we're working again with some real world scenarios where we might use this. Trigonometry is really important when we're getting into construction and anything where we're going to have to be building or realizing, like for thinking about like crane operators, things like that, you're always using trigonometry. So this one says Sylvie and Matthew are bird watching and they both spot a nest at the top of a tree. Matthew is 89 meters from the tree, and the angle between Sylvie's line of sight and Matthew's line of sight is 73 degrees. Then it also tells us the angle of elevation from Sylvie to the top of the tree is 35 degrees. It's asking us for what is the height of the tree. So I'm looking for the height here. And this is nice. It's given us a diagram already labeled. So if I'm looking for the height, I'm going to start and look in that triangle and go, okay, I have the height, I have an angle, but I need one more piece of information in order to solve for the height. So I have two triangles, and this line here is shared between the two triangles. So that's probably what I need to figure out. The nice thing, if I look at this bottom triangle, I have a 73, and I have this 89 here. This 89, if we look, is the opposite side to that angle, okay? And I'm gonna label this side X, this one that goes across here, okay? And that is going to be the adjacent to the 73, okay? Because it's helping form that angle. Oh, do you know what? It's not adjacent. I need to correct myself. So this 73, it's actually the hypotenuse. If we look, the 90 degree is right here where Matthew is, and it's across from that X that I'm looking for. So I'm actually using the hypotenuse and the opposite. So that means I'm using sine. Okay, so sine of 73 degrees is equal to, oh, I'm sorry, make you dizzy. So my opposite is the 89, and I'm looking for X. Okay, and if it's helpful, throw that one underneath. So I'm gonna take 89 times 1 divided by sine of 73. So we'll get a distance of 93.1. Okay. So that's what goes here. Okay, that's the hypotenuse. It should be the longest side. It's greater than 89. We're doing okay here. And now let's look at this triangle that includes the tree. So I have 35 degrees. This 93.1 is my adjacent, and the H is my opposite. Okay, so I'm going to use tan, because I have opposite and adjacent, of 35 equals H over 93.1. Okay. So I'm going to take 93.1 times 10 of 35. And I'll get 65.2. And the dimensions are given in meters, so that will be the height of the tree. Okay, so again, we're using one triangle to be able to get information to solve our final triangle. And then our last question here. So it says we have a distance from an airplane to a control tower, okay, is 36.2. Okay, if we're drawing a straight line as quick as we can get there, the angle of elevation from the airplane tower is 4 degrees. And the airplane is 24 kilometers south of the tower. So we kind of have two triangles happening in here, but we have drawn it out for you already. So how much west of the tower is the plane? So if north is going this way, okay, so we have north, east, south, west. I'm looking west, which will be this distance here. So that's overall what I would like to find. Now, I only have one other piece of information in that triangle. I have that 24. So I'm going to have to figure something else out, which is likely going to be this distance here, okay? So I'm going to use this angle of elevation of 4, okay? And I know that in this triangle, and it's kind of hard to see here, because it's very small. I'll redraw that. Okay, maybe we won't draw. Okay, this 36.2 is the hypotenuse, and I'm looking for the adjacent, so I'm going to use cosine of 4 degrees is equal to, let's call this x here, adjacent over 36.2. So to figure out that distance, I'm going to go 36.2 times cos of 4, which will be x is 36.1, and this is in kilometers. So that means that this is 36.1. So now I'm looking for b. I still don't have an angle in here, so I have to use Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared. And I want you to notice here, this 36.1 is the hypotenuse, so that's going to go in for c squared. 24 is my other piece of information. Okay, so if I rearrange this, okay, I have to take my hypotenuse minus the other side length. So I'm going to take 36.1 squared minus 24 squared. And you have to take the square root of the number that you got. So I'm getting that we are 26, and it's 0.96. So I'm going to round this to 27 kilometers west. Okay. So that completes the trig section of the course. And really, it's using the same information that you've learned already from grade 10, but we're just applying it to different scenarios. You're having to solve different, more than one triangle at a time. And sometimes you might have to break up shapes or kind of decipher what it's asking. These are typically more than one-step problems, okay? If you have any questions, let me know. You do have an assignment for chapter 4, so make sure you get that done and sent in to get graded. And there'll be a Google form on the classroom for you to practice for trigonometry, as well as the your practice workbook. And your unit test for chapter 4 is included with chapter 1, which is on slope, which will be the next section that we're covering.